Okay, so this is a video about analysing data. So spec point 1.8 is about the questions that they're likely to ask you following on from the cardiovascular disease. So they're likely to ask you about how the blood vessels get blocked, etc., how it leads to heart attacks and strokes, and then they're likely to give you some data to analyse linked to that. So I'm just going to give you a few kind of tips. So first of all, when they ask you to describe a graph, let's think about the things that we're going to include in our answer to describe a graph. Okay, so the first thing is, let's draw a little graph so we can imagine what kind of thing we might be looking at. So the first thing is we need to look at some kind of overall trend. So let's say we've got a graph that just went up. Okay, so the overall trend is that it increases. If we had a graph that looked like this, we'd say it increases and then it plateaus. If we had a graph that looked like this, we'd say it increases, reaches an optimum, and then it decreases. If we had a graph that goes like this, we talk about it, how it decreases and gradually plateaus. Okay, so when we start off describing our graphs, first thing we need to do is we need to talk about an overall trend. Okay? So that's using words like increasing, decreasing, etc. And what we need to do is we need to then go into each section. Okay, so then we're going to describe each section. So when I say that, what I mean is let's have a look at these graphs that we've drawn. So in this one, we've only got one section. In this graph, we've got section 1 and section 2. In this graph, I've got section 1, section 2. Here, I've only really got one section. So we need to describe each sectional graph. Now, of course, you could end up with a graph that was more complicated. You could end up with a graph that went up, across, up, across. You could end up with a graph that went up, down, up, like that. In which case, you've got more sections, haven't you? So you need to talk about how it went. In this one, how it's going up and it's plateauing, and it's going up and it's plateauing. And in this one, how it's going up, then it's decreasing, and it's going up again. Okay, so you need to start describing each section, and there's certain words that pick you up marks. So, so when we're describing each section of our graph, the kind of words that we're looking for now well, really what I was saying already. So we're going to talk about increase, decrease, plateau. So whenever you get a flat section on a graph, we call that a plateau. If it goes up and down, we could say it fluctuates. Okay, so using those words to describe each section of the graph. Okay. When you're describing each section, you need to be really careful that you reference the numbers on both axes. Okay, so reference values on both axes. So you could say that, it increases from 0 to 10. Do use the words that it says on the axes and the units if there's units, and then it decreases from this down to this. Use values from, I should say, from both axes. With units. Okay, so you're really, really specific in your descriptions. The next thing is to compare the sections. Okay, so when you're comparing the sections, we need comparative language because we're comparing, we have to use comparative language. So comparative language is things like higher, faster, slower, more, etc. Okay, a lot of comparative words end in er, but you could use more or less as well. But comparative, so section 1, is increasing faster than section 2, yeah, or it increased it faster between 1 to 10 minutes than it did from 10 to 20 minutes. So compare your sections of your graph. Then kind of for a step up on your comparisons is to do quantitative comparisons. So that means saying things like double, triple, half. Okay, so not only are you saying it's less, but actually it's half as much. You're not just saying it's higher, actually it's double. Okay, so a quantitative comparison is words like that, which do well. And the last thing is to always do a calculation. There'll be a mark usually in the mark scheme to say that you've done some quantitative manipulation. That means you've done a calculation. Now, what I suggest you always do is if you always work out percentage change, you can't go wrong. You just get in the habit of it. So you describe your graph overall. You describe each section using the right language, using numbers, using the units and the words from the axes. You say which one is higher or lower or twice as much or whatever, trying to use those comparative words. And then the last section, you just work out percentage change. It doesn't even matter which bits you're comparing, as long as you do some kind of calculation, they'll give you the mark, unless it specifies, of course. So the equation for percentage change is however much the difference is, okay, divided by the original value. I'll give you an example in a minute, and then times it by 100. So let's put some numbers on a graph just so we can see what I mean. So if we wanted to do percentage change on this one from 3 to 4, if the value at the start of 3 was, let's say, 2, whatever it is, on there. So let's say there's a value of 2 there, 3 there, 4 there, obviously 1 here. Okay, in section 3, it's gone up from 2 to 4. So the difference in that example, if it's gone from 2 up to 4, the difference is 2. The original, that means what did it start from? It started from 2, so 2 divided by 2 times 100. Okay, that would be your percentage change. So 2 divided by 2 equals 1, times 100 equals, obviously, 100. So it's gone up by 100%. All right? So try and just work out a percentage change at the end of any describe it graph question, and you should do well. Okay, there's a couple of other words that you can include in your answer. So two words that come up quite a lot are causation and correlation, and we need to be really careful that we understand the difference between these words. Okay, so a causation is not necessarily a correlation. Or, sorry, other way around. So a correlation is not necessarily a causation. So graphs show correlations, all right? That's what graphs show. So, for example, as x increases, y increases. Whatever is on the x-axis, whatever's on the y-axis. So, e.g., as x increases, y increases. That's a correlation. That doesn't tell us that x caused y. Okay, so causations are not shown by graphs. Okay, graphs show us the correlation. Causation needs to be proven by other scientific investigations where they find out and prove what step-by-step process happens to cause that, to link that causes that to happen. Okay, so it needs to be investigated to find out the step-by-step process of how X causes Y. And it's not going to be shown by a graph like we've been looking at. Okay, so just be aware that of those words in case they bring those in or in case you misuse them. The last little thing that's come up in these kind of questions is they say, oh, we've done these multiple studies, or scientists have done these multiple studies, but the results are conflicting. What should the scientists do next? And the answer to that is they need to widen the field of surveys. So they need to be doing more varied studies. Okay, so if results show conflicting results, they need to widen the field of surveys, of studies, we should say, really, isn't it? Okay, so they just need to keep studying more and more wider things until they start to see some kind of correlations happening. And then once they have the correlations, then they do their investigations to try and look at what is